have convened a number of social scientists here in this Musée des Arts et Métiers to have a final event after 3.5 years of work together with colleagues of LISIS and others, devoted to one topic, which was how does computers and computational models, how are these things used by policymakers in government, and how do these things influence the way we manage the environment, the way we manage security problems, the way we manage nuclear risks, for instance. And we spent 3 days discussing fully those questions. This conference was entitled Governing by Prediction, ? Models, Data and Algorithms in and for Governance. And with those terms, we wanted to capture the various ways in which, computers and the statistical models, the data, the so-called algorithms, how are these things actually used in practice for policy purposes by governments. These 3 days concluded a project that lasted over 3 years, and this project was funded by the Agence Nationale de la Recherche, ANR. It was mostly performed by people in the LISIS, our Laboratoire Interdisciplinaire Sciences, Innovation, Société, which is supported directly by CNRS, INRA, the National Institute for Agronomic Research, and Université Marne-la-Vallée, all of which have supported this event. During those 3 days, we had colleagues from sociology, history of science and technology, political scientists. We had colleagues from the discipline of geography, coming from Great Britain, coming from the US, coming from Germany, and of course from France. And all of them interested in detailing really the kind of technical knowledge that we produce through computers, and how that frames the policies, the decisions we take, again, in matters, in environmental matters, in security matters, for instance, in agricultural issues, and whether this was, and how democratic, in a sense, this was. Does this allow debating the policies, or doesn't it close sometimes the debate about these policies? Doesn't it narrow the range of decisions we can make about these complicated issues and risks? These were some of the questions on our agenda. We had the chance of having three key scholars to cover the various things we were interested in and who helped us treat those problems on our agenda, sort of. So Steve Hill-Gartner from Cornell University came to explain to us how hurricanes are modeled, evaluated, and more or less prevented thanks to systems of simulation and computation. Then Claudia Arradao from King's College London came to us to explain how network analysis and other computational methods are used to anticipate terrorist risks, in particular, and security threats, and very interesting already existing applications of these methods in security policies. We ended the event with a fascinating keynote by Paul Edwards from University of Stanford and Michigan. Paul Edwards is the specialist of the history of this system by which we know the weather and we predict changes in the climate. And he explained to us how the challenges that climate modelers and climate forecasters nowadays face in a context where climate change is as we know, contested and debated. I was very struck by the fact that if you look at climatic issues, if you look at energy issues, choosing between solar energy and other modes of energy, questions of agriculture, what kind of crops should we spread over the planet to address food security, I was struck by the the fact that in any of these situations you have a diversity of people who propose, who come with their own data, who come with their models, their statistical models, their mathematics, and who want to suggest that the right policy should be this or that, and therefore that we are not anymore in a situation where you have the expert, the statistician or the mathematician who can tell to the policymaker what to do. But you have a diversity of propositions on the table, a diversity of models, and somehow some conflict between those people, those models, those computations, those sets of data. Paul Edwards just talked about the conflicts around climatic and meteorological data, for instance. And therefore, modeling and computers do not offer us the solution anymore, but they offer a sort of language to debate about policies. Like many projects, one of the results of this project is to discover new, perhaps even better questions and the interesting research to do in the future. One of the things we have discovered, again, is that models and data, however objective and however authoritative, are also often contested and very controversial. So there's still a lot of thing to do about I would say, the politics of data, the politics of modeling. And we have a number of people here in France interested in the application of models to the management of nuclear waste, for instance, to the management of climate change, to the management of energy sources, and we could mention also the management of health risks from chemicals, environmental risks, and I guess we're going to make an effort to bring those people together to keep debating those important questions.